Bismillahirrahmanirrahim. Assalamualaikum. Hope so you all will be fine. Today we are going to discuss an harmonic oscillator. Initially we have studied the harmonic oscillator, and now we are going to add a perturbation in that harmonic oscillator, and we will see that how that harmonic oscillator act in the presence of that perturbation. So the unperturbed Hamiltonian for the harmonic oscillator will be something like this. We have discussed it earlier. Now we are going to add a perturbation term, and we will actually take the x4 perturbation, x to the power 4 perturbation, and we will made a Hamiltonian for this perturbation, and then we will examine the first order correction in energy by using that perturbed Hamiltonian. So first of all, we have to define our length scale. It is in term of h cut, omega and m, and here is the derivation of that length scale which have been discussed or which have been defined in term of h cut over m omega. This is something very simple in physics in the way that let us say that we want to express the length in term of force. So we will do something like let's say F is equal to W equals mg. So if we take just for a while, so if we take a black curve for this, so let's say W equals fs. If the angle between f and s is actually 0 degree, then we can say that W equals fs. So s is equal to W by f. So this is the way we want to, or we are going to discuss, or we are going to express this s or this length. In the same way we have done over here, and we have we have expressed the d in term of h cut, m and omega. Here we have write this s in term of w and f, and over here we have write this d in term of h cut, m and omega. And now the question is that why we are doing this. We are actually dealing with the harmonic oscillator, and we have seen the Hamiltonian that of this harmonic oscillator, that is it is in the form of these things, and this is in form of p, which is the it's actually the momentum. Here it is m, and here it is omega. So m and omega, this h cut is actually the of the dimensions of momentum, m and omega. So all those terms which are present in this Hamiltonian are actually present in this length term, and we have actually expressed this d in term of this h cut, m and omega. So let us construct our Hamiltonian, the perturbed Hamiltonian, and this Hamiltonian, as it is actually the energy, so here must be something which is related to energy, and in our harmonic oscillator the energy term is like this thing, and it is in the term of h cut and omega, which have the dimension same as those of energy. So we have taken this as h cut omega, and after that we have multiplied it with the x to the power 4, which is actually our perturbation, and divided by d power 4 actually balance the dimensions. Now if we talk about this x, so we have already defined this x when we have talked about harmonic oscillator. So we have discussed and we have defined this x, and we are going to use that definition over here. And with some simplification, if we put the value of d in term, if we write this d in term of h cut m omega, and we put these values, and we will after some simplification we will end up with actually this equation. So x power 4 to the divided by d power 4 will actually be equal to a plus a dagger whole power 4 divided by 4, and we will put this in equation number 1 over here. So when we will put this thing over here, we will end up with our Hamiltonian, the perturbed Hamiltonian, which will be something like this, and over here lambda with this lambda will goes, and we will end up with this Hamiltonian. Okay, so as we know that the first order correction in energy can be written something like this. We have already derived this formula in previous lectures, so we are going to use that formula over here. So let us put the value of delta h cut, and here it is. So h cut omega over 4 into a plus a dagger whole power 4. It is applied, it is we are going to apply this on the state 0. This we are going to apply this on in this state. So how we will apply this, here are the definition of this raising and lowering operator. Sorry, this is actually a plus, and this is over, definitely this is a dagger. So we are a plus, this is actually so okay, this is actually the a plus, which is the raising operator, and this is the lowering operator, or creation and annihilation operators we also say like that. Here is actually the definition of these operators. So a, when it is state it applied on the state n, it will lower down the state, and along with it give us eigenvalue something like this. Also it this thing will give us this state, and along with the eigenvalue n plus 1 square root. Okay, so when we will apply this whole thing over here, we will end up with the value 3 along with these two states, which will go to actually 1. So it's your task to open this fourth power and apply this thing on this, and let me know that it will do like this, or it will be like this or not. Now if we have this, the first order correction in energy, then let us put this value over here. So this is actually the 0th order energy of the harmonic oscillator, which we have already calculated in previous lectures. We have write it over here, and then for the first order correction in energy we write this term, and here it is the for the second order and third order up to so on.